Hi guys, welcome back. From this video onwards, we will discuss about DC missions, DC missions unit. In this unit, we have two broad classes, I guess. One is transformers, and another is like DC motors by generators. Uh, we will first concentrate on this transformers part. Then we will go for this DC missions and DC motors part also. First, we will focus on this transformers part now. And in our syllabus, we have only single phase transformers, and we don't have any three-phase transformers. So I will limit myself to this single-phase transformers. That's it. First of all, diving into the topic. Before diving into the topic, just we will discuss about what is meant by transformer. What is a transformer? The transformer is a device that transfers electrical energy from one electrical circuit to another electrical circuit. The two circuits may be operating at two different voltage levels, but always work at the same frequency. Basically, transformer is an electromagnetic energy conversion device. It is commonly used in electrical power systems. Yeah, they have given some definition about a transformer, but why transformers are used? Means what is a transformer? Transformer is an electrical device which converts electrical energy from one circuit to another circuit. It's obvious. Like why we use transformers? Like we have in line, we will get 11 kVA voltage, right? 11 kVA, 33 kVA. We will get the voltage in kVA, like kilovolts amps. It is an unit for electrical energy. So, but when we consider the household voltages are like 220 volts to 250 volts. That's it. We have to limit the voltage inflow into the household purposes between this range itself. So, for this purpose, we have to step down this 11,000 kilowatts to 220 watts. And whereas in the line, if you are going to transport heavy currents, then it might cause loss, a lot of electrical losses. So we will what we call transform. We will transfer low currents with high voltage from one place to another. Here we will use in a particular location where we want to send this high what high voltage and low current energy into household purposes where we need low voltage and high current. So we use transformer, which is a step down or step up based upon our what we call needs. We will step down the voltage or step up the voltage, and we will step down the current or step down the current, and we will use it for our further usage. We will discuss about all these step up and step down transformers in our discussion. Let's deep dive into this. What is meant by single phase transformer? Introduction. In a simple form, a single phase transformer consists of two windings wounded on iron core. One of the winding is connected to its source of the supply. F. The source supply a current to this winding called primary winding. Just remember this primary and secondary. The whole transformer part is based on primary and secondary volts. Primary winding, primary coil, primary number of turns, secondary number of turns, primary EMF, secondary EMF. We are going to discuss all this. We are going to have whole discussion on these topics only. Just see. Which in turn produces a flux in the iron core. That in the sense, we have some number of coils, we are passing some current through it, so it produces some flux. That is the meaning up to this. If the supplied voltage has a frequency F, the flux in the core also alternate at a frequency. If you're applying continuously plus and minus current to it, then the magnitude of means the magnetic induced here also will have some frequency. This frequency of magnetic field that was induced will be equal to the frequency of the current that we are applying to this coil, right? As we everyone knows, if a current flows through a coil, then automatically magnetic field develops around it, right? Same principle is used in transformers. The alternating flux linkages with the second winding. Yeah, the the thing why what we call the magnetic flux developer, right? We will use this magnetic flux to develop current in the secondary coil. Here we will have some another secondary coil. This magnetic flux will be passed through this coil, so that if a magnetic flux is passed through a coil, then automatically it generates electricity through this coil, right? Same principle is used. First of all, what we are using here, we are using one of the connector, means coils of conductor. Then we are passing some current with a frequency, current or voltage, which induces a magnetic flux in it. We are using this magnetic flux and what we call in secondary coil, we are using this magnetic flux and generating some amount of energy out of it. That is the whole working principle of a transformer. That's it. And we have like what is this formula? I will continue reading on the secondary winding induces voltage E2 in the secondary winding. Note, the alternating flux linkage with a primary winding will also induce a voltage in the primary winding. Denotes E1. Applied voltage V1 is very nearly equal to E1. If the number of turns in the primary coil and secondary coil is N1 and N2 respectively, then we shall see later in this unit that E1 by E2 is N1 by, like just like if we have N turns, N1 turns in a primary coil and we are applying E1 voltage to it, and we have N2 turns in secondary coil and we are getting E2 voltage out, then we can write this formula E1 by N1 equal to E2 by N2. It's further modified as E1 by E2 is equal to N1 by N2. You are able to get it right. Like it's a basic common sense. We are passing even amount of energy through N1 coils, and we are taking out some E2 amount of energy from N2 number of coils. We can directly relate these things. And this is a typical representation of a transformer. Just like, see, here we have N1 coils. It's a primary winding. We call it primary winding. It's secondary winding. And here we are applying the what we call here we are applying some voltage or current to it, and we are taking out the load from here. Just see, these are the terminals, output terminals, and the load will be applied between A1 and A2, and we will use it for our use cases. That's it. This is a basic introduction about transformers. Now we will look at the construction of a transformer. Transformer mainly contains two parts. One is magnetic core, another thing is winding or coils. First, we will discuss about what is meant by magnetic core. Magnetic core in the sense, the core of transformer is either square or rectangular in size. It's further divided into two parts. The vertical portion on which coils are bound is called limb, while the top and bottom horizontal portion are called yoke of the core. Just see, we have some square or rectangular pole where we are going to some wound the coil. We are going to supply current voltage, voltage to this coil, through which we will get some magnetic flux, and this pole will behaves like a magnet, right? We are now we are denoting it as a magnetic core where the magnetic flux develops. We are denoting this pole as a magnetic core, and we have two parts in the magnetic core itself, just like horizontal part and vertical part. The horizontal part is known as yoke, and the where the coil is mounted is known as limb. The remaining three parts are known as yoke. Now, core is made up of lamination. Because of lamination type of construction, eddy current losses get minimized. Generally, we will discuss about what is meant by eddy current losses, all those things. Generally, high-grade silicon steel lamination, 0.3 to 0.5 mm thickness are used. These laminations are insulated from each other by using insulation like varnish. Just go through this every point that I tested over here. because every point is very much important for your end semester exam. All laminations are varnished. Laminations are overlapped so that avoiding air gap at the joints. For this, generally, L-shaped or I-shaped laminations are used, as shown in the figure 3 below. See, these are the different types of laminations are used. Because if you are not going to use any lamination over this course, there will be some losses to the atmosphere, not to the atmosphere exactly, to the oils present in the transformer itself. We will use some oils which may conduct the electricity. Like we have some other losses also. We will discuss it later. And we have to, so that we have to laminate that course so that current won't discharges out of that coil. That's the main purpose of lamination. We have discussed about magnetic core, right? Now we will discuss about winding. What is meant by winding? There are two windings which are wounded on the two limbs of the core. This is one limb and this is another limb. I said right. This is primary limb. This is secondary limb. Here, primary limb is the thing limb where we apply input input supply, and secondary limb is the place where we take out the load. Right? The windings are made up of copper so that they possess very small resistance. Like this, these windings are made up of the windings are made up of copper so that they possess very small resistance because every small minute loss will be calculated over here. We will have two major type of losses. We will discuss it in the later stage of this chapter. To have a minimum loss, we use these windings to be made up of copper. The windings which are connected to the load are called secondary winding. The winding which is connected to the supply is called as primary winding. I said right. The primary winding has n1 number of turns and secondary winding has n2 number of turns. It has n1 number of turns and it has n2 number of turns. This is the basic construction of an transformer. And principle of I explained this principle of operation of single phase transformer in the first slide itself. Like we will apply some voltage over here which induces some magnetic flux over here. This flux will be carried out to another limb. As the magnetic flux passes through this limb, it develops some current in this coil, which is used, which is taken out for our purposes, and we will attach some load over here. And we have derived some formulas for all the stuff. These formulas are not of use actually. I just wrote it here for some curiosity. Some guys might have curiosity how the things evolved, all the stuff. For derivation of this formula, E1 by E2 equal to N1 by N2. This is the what we call step behind it. You have to use this formula. That's it. We will use this formula in our problem solving. That's it. I hope this is all for this video, guys. I explained basics of the transformers in this video. We will meet you in next video. Bye.